So now let's see what is empirical formula. Now an empirical formula is defined as the simplest whole number ratio. For example, if I have H2O2, this is hydrogen peroxide, then the empirical formula for this would be HO. Simplest whole number ratio. So here the ratio is 2:2. So the simplest whole number ratio would be 1:1. Similarly, if I have C3H6, for example, so the ratio is 3:6, then the simplest whole number ratio would be 1:2. So then the empirical formula would be CH2. Here, the actual formula is called the molecular formula. So here, that would be the molecular formula, and this would be the empirical formula. So the molecular formula is the real ratio of the atoms in a molecule, while the empirical formula is the simplest whole number ratio. So simplest whole number ratio. This is about the definition. Now, how do we calculate empirical formula? It's a very simple step. It looks a lot, but let's see how we do it. I've put it in the form of a table, but when you are going to get exam questions, you will not have a table to fill in, but you can draw your own table, or you can just do it in rows. You don't need to draw a table. Make sure that you know which information that you're going to use. So we have a gaseous oxide of nitrogen and oxygen. So it contains nitrogen and oxygen. So these are the elements present. So the first thing that you do is that you write down all the elements in the compound. So nitrogen and oxygen. Then you are going to write down the mass of each element or the percentage of element in the compound. Sometimes the question will give you mass, sometimes the question will give you percentage. Here it's given percentage, so I'm going to write down the percentage of each element. Okay, and then you're going to write down the AR of each element. So look in the periodic table. Nitrogen is 14, oxygen is 16. I'm writing down the AR. Then I will do the percentage by mass divided by the AR. So 30.4 divided by 14 and 69.6 divided by 16. Calculate this. So I've calculated these two. Now you are going to find the mole ratio. So the mole ratio, how are we going to do that? We're just going to divide by the smallest, because we're assuming that the one which is found in the smallest one is present as one atom. So we're going to divide by the one which is the smallest. So from these two values, so this is the smallest. So 2.17 divide by this, I'm going to get 1. So I'm assuming that nitrogen is present as 1 because it has the smallest percentage divided by AR. And so this is actually representing the number of moles, actually representing it. It's not the number of moles because we're using percentage, but it's representing it. And here I'm going to divide by, again, 2.17 because this is the smallest number, and I'm going to get 2.0. So the simplest whole number ratio is 1:2. Let's say here I would have got 2.3. I would still round it up to 2. If I would have got 2.9, I would have rounded it up to 3. But if I would get 2.5, I cannot round up or round down. What I will do, I will keep it as 2.5. So let's say I would have got 1:2.5. What I would do is I would times this by 2 and I would times this by 2. So then I would get 2:5. Okay, so this is a special scenario where you don't get a whole number, but you will either get something that can be rounded up, rounded down, or that can be multiplied by 2. Okay, so and this is the simplest whole number ratio. Therefore, the empirical formula will be NO2. Okay? Now, I'll do the second example because it is a little bit different. So, magnesium was burned in oxygen to form magnesium oxide. You need to find the empirical formula. So, magnesium oxide has the elements magnesium, oxygen. You know the mass, the total mass of magnesium oxide, and you know the mass of magnesium. So, magnesium is going to react with oxygen and is going to give us magnesium oxide. Okay, now balance the equation. Here you go. Now we are working with masses over here, 0.8 grams, 0.48 grams. Now if you still remember, there is something known as the law of conservation of mass, which says that mass can neither be created nor destroyed. So here means that the mass of the magnesium and the mass of the oxygen used should totalize this. So we can get the mass of the oxygen used in that reaction. So from that 0.8 grams, we know there is 0.48 grams of magnesium. So we can get the mass of oxygen, which is going to be, so mass of oxygen is going to be 0.8 minus 0.48 grams. So here we have mass. So in this question, we're working with mass. So here is just going to be mass. Now the AR, 24 for oxygen is 16, percentage divided by AR here, and we're going to divide by the smallest. So if you look at these two values, they are the same. So this is just going to be 1 and 1. So simplest whole number ratio, 1, 1. So empirical formula is MgO. So you are going to try these questions here. I'm going to give you the answers when we meet again. Now, molecular formula. So, like we've seen, the empirical formula is the simplest whole number ratio, but the molecular formula is the real ratio of atoms in that molecule. And if you look at these, you will see that the molecular formula is a multiple of the empirical formula. So here we're multiplying by 3. Here we're multiplying by 2. If I have this empirical formula and so if I have this empirical formula, for me to find the molecular formula, I know that I need to multiply by a number. So I need to multiply by a number. Okay, so if I know this number, I can get the molecular formula from any empirical formula. So this is what we're going to try to do. So here, a molecular formula is X, which is any number, any integer number multiplied by the empirical formula. So let's see how we do this. So empirical formula of a compound, this is given in this case. The molar mass is given. You need to find the molecular formula. So what I'm going to do, I'm going to find the MR of the empirical formula. So this is the empirical formula. I will get the MR of this. So 12 plus 2 times 1 plus 16. So this is the MR of the empirical formula. The MR of the molecular formula is given. So MR of molecular formula, this is 90. And the value of X, I'm going to go and find that value of X. X will be obtained by the MR of molecular formula divided by the MR of the empirical formula. So here is 90 divided by 30, that's going to give me 3, which means that X is equal to 3. So for me to find the molecular formula is going to be 3 times the empirical formula. So CH2O, all of this is going to be multiplied by 3. So it's going to be C3H6O3. So this is the actual formula of that compound, that molecule. Okay, so in this case, the empirical formula was given, but in this one, the empirical formula is not given. So you're given the percentages. So first you need to find the empirical formula. Then you're going to use the MR to find the molecular formula. So try to do this, and this is the last sheet for the mole concept chapter.